method have the advantage we can in the test 2 we have a good result in the advantage SSFD. And actually, I want to let you know that we do not perform well in test 3. We will let you know the why in the further discussion. And actually, we still have some limitation for proposed SSFD. The first one is IP coordinate transformation. If we encounter the sleep domain problem, what is sleep domain problem? They will have some latent in your computer, and they try to transfer the IP to the virtual IP address or the local host IP address. And it is hard to map to the geography coordinate address. And sometimes we also encounter the missing value problem in coordinate database. So this is another limitation that we need to update our coordinate database. And another thing is attack classification. Sometimes some attacks try to use single IP address in DNS response problem. So for example, they just use one point to do the detection. Actually, we will let you know in the next slide that sometimes we consider the limitation. Also, we also want to consider the attacker's cost. If they want to do that, they might need a lot of cost. Because a point in structure is not useful for FFSD, fast-flux service network. And one-to-one or one-to-many relation problem. Okay, we also discussed if the head attacker try to use following evading techniques, how the impact for our method. For example, they try to use spatial uniform distribution. Well, they try to make themselves less uniform or even a point of invaded host. Okay, in this case, spatial service relationship with invariance approach. So actually we still can consider because they uniform their distribution. However, we also see the minimum service distance, so we can take care of these things. And also spatial service relationships. They try to use dynamic DNS service. Okay, in our method we could not detect that, but attacks would make an additional effort to select similar IP address. Okay, and the next is if they evade both characteristics, they locate in the near area. For example, they locate at the Taipei, and they at a single site. However, actually we could not detect this kind of cases in this case. But this is a difficult task because actually they want to spread them to the different location. So if they located at the same place, it is easier to find their sources. Because SSF, fast-flux service network, try to hide their original target, these sources. Okay, now I try to do some conclusion and further work. The first thing is that we contribute an idea about spatial snapshot mechanism to delay fast-flux detection. In addition, we provide a novel spatial measurement, the two measures, and we perform more efficiency and effectiveness in fast-flux detection problem. And the further work is sometimes because our system is without the concept drift adaptations mechanism. So it might be another issue to do the adaptation. In addition to these issues, sometimes it is hard to get a lot of labeling data. So in data mining, they try to use active learning to try to sample some informative instance for labeling and do the further training. Okay, the second issue is bounded detection by similarity measure. Because sometimes we observe that the same IP address from multiple domain names in the same botnet. So maybe we can design a similarity measure to find some IP address similar, and we say, oh, this might have a high suspicious as a fast-flux service network. This thing is an open problem in this field, that sleep domain. it might be leverage who is analysis. This is our guess, not make sure that it could be solved. Okay, this is my presentation.
Questions?
It's very interesting work. One question is, what if the attacker use proxies to reduce the service distance? In this way, the attacker avoids moving the real service nearby, which is not good for attacker. But the proxies could be lightweight.
Actually, Fast-flux service network is a process service. It's like a process service, like you mentioned. Yes. So actually, if they try to move their process, lightweight process to different hosts, for example, they escape anywhere, and I think it needs a more rapid detection mechanism to capture that. But I don't know. I'm not answering your questions.
I imagine that the attacker will set up some very lightweight proxy nearby the consumer or provider.
Yes.
And then the DNS, once compromised, okay, will send the IP address of the consumer, if I'm correct, to the client.
Yes.
And then the consumer will forward the request to the proxy. And then the proxy and the real service provider will have a hidden TCP session to send the proxy should know the real server's IP address, and then send the request, forward the request to the real server, get a reply, and then send the content to the customer.
Yes.
That's what I imagine. In this way, from the client or from your detector point of view, you may only see the proxy IP address and the customer IP address, but they could be close.
Yes. We think we can consider these cases. Yes.
Right, so let's send our speaker again. Our third speaker will be Taiwan.